Hello.
Hey, what's up? How are you?
I'm good. How are you doing?
I'm doing pretty good. Yeah, I saw your YouTube channel. I was like, I kind of need some like help slash advice. So
Awesome, awesome.
I reached out to him. So basically, I took the MCAT last year.
Yes.
I'm kind of like a pretty non-trad. Like I majored like health science, exercise science. I was gonna do physical therapy, and I changed my mind. So
Yeah.
I kind of switched over, and I did pretty well in all my classes. But MCAT's kind of a beast, and I work a lot too. I'm supposed to take it again like the end of July, but I may have to push it back. Like
Mm-hmm.
I don't need a super crazy score or anything, so I'm trying to stay in Florida. That's where I'm at.
Yeah.
But I like to get at least like 510, ideally.
That's a good
Been
score.
doing pretty bad. Except like so like I took the FL1 like about a month ago, and I didn't take another one. I used the third party stuff just because I didn't want to
LTS?
like waste them, I guess. Like I want to make sure my score went up. But I got 129 on like SOS, and like everything else is like low 120s.
Got it.
I've scored anywhere from like 120 to 128 on bio. Chem Phys is generally around like 123, 124, and cards is around there 123, 124. I just cannot get my scores to go up,
Yeah.
and I noticed like reviewing things like granted like my content's not like phenomenal or anything. It's like decent with biochem. I know like my math is not great. Like I just get kind of anxious with it. I have a hard
Yeah.
time. I didn't take anything past college algebra because I didn't have to. Like I even take trig sigma physics. Like I did well on it, but like it was pretty much just memorize your formulas,
Yeah.
solve this, and like I forget everything. Like the MCAT's
Yeah.
just totally different. So I noticed like my issue is a lot of timing and like just the reasoning through the
Yeah.
passages. Like going through this last FL I took, like I missed 10 or 15 questions on the Chem Phys section just from me not making enough inferences in the passage and just
Yeah.
like careless mistakes. So I
Okay.
think that's like the biggest issue. Um,
All right. So I can. So do you want to share your screen? We can just
yeah,
start right getting into it, and we can do basically like how to reason through the passages and how to do the math.
cool. Do you want me to start, like, I could start with either like AMC stuff, I could go through this LTS exam, like go through some of it, show you what I'm missing, or I could go through UWorld. What do you want to start with?
Oh, you could go through like I guess your most recent exam that you took.
Okay, cool. Yeah.
So yeah, whichever that is.
Let me just go back to the beginning.
Mm-hmm.
Um, stuff I always like to see.
I see a decibel question.
Do we go back to like the very beginning?
Yeah,
Like,
yeah. You can go
okay.
to. Oh, there's no navigation or whatever.
Yeah, I don't think there is. Hold on. Yeah. Most of these, like, I can go through kind of quick, but the math ones are tricky.
Mm-hmm.
I'm sure there's a faster way to do this. Let me just go out and go back in. Okay, yeah. So this first question, like, I was kind of stupid with the choosing R. I did not catch on after reading it that it didn't have a stereo. It wasn't to have a stereoisomer or whatever, or it wasn't chiral. So I should have eliminated those two.
Oh wait,
Um,
you're saying okay. So
yeah, it was this one,
is
this
something?
molecule right here, and I
Yeah.
found it right away. I was like, oh, sorry. By the way,
Mm-hmm.
you think it's better to like just read the question and then go to the passage because
Yes.
like I'll run out of time, and
Yeah. Yeah.
the
Go.
only issue I have with that is
Mm-hmm.
like this test, like I was running out of time. Like I had like 15 questions left, and I'm just like running out of time.
Yeah.
And I notice if I read slower, I do pick up more things
Mm-hmm.
than if I read the question. But it kills time, so there's no way I can like comprehend it and like remember. Because I'm gonna have to refer back. It's just
Yeah. Yeah. Keep in mind that a passage is just 5 questions. So if you just go at it like question by question, you'll realize that a lot of the stuff in the passage you don't even end up using. Because
okay.
all the passages they're basically just from like research like papers. They're not from like a textbook, so they're not really stuff that you're expected to really understand right away. Like if you go
Yeah,
down
yeah,
to the bottom of that passage, I bet it'll say like
yeah.
well
Usually
I
they
guess
do.
Altius
Yeah.
doesn't, but usually like for AMC and stuff, like they'll give you a citation and it's like some passage from like, or it's some paper from like Nature or something like that.
Yeah, for sure.
So
and this test, like I said, like I'm starting to finally see things like even watching your videos was helpful. Like that a lot of stuff you can make inferences from the passage and not really know all the content. And it's like I've been wasting my time. All these people tell you, oh, like you need to know so much content. And you do need to know things, but like I would be like 10 points higher now if I wouldn't just make dumb mistakes from using what they give me, you know?
Yeah. I mean, like when it comes to content, like I think it's best to like do the exam, figure out what content you don't know, and then learn that. So for this question, the thing you're saying about chiral, so like R and S, so all right, if something is chiral, that means that isomers can exist for it, but R and S is just for like the chiral carbon itself, like one carbon that's just attached to 4 different things. So, but since they're talking about the overall structure, then it's going to be either like Zusammen, it's like German, or Eingegen, like Z and E.
Yeah. So for this one, isn't Z like cis and E the
like on the opposite side, Yeah.
I had a hard time kind of like reading that. So like based on the double bond here, your highest priority groups for Z are on the same side of the double bond.
Yeah.
So I'm having a hard time seeing that.
So see how it's like that.
Yeah.
I should get my like tablet out, but if it was like hold on. Okay, so maybe. So
I think it's because aren't there, because there's an H bond here, and there's an H bond here, and is it because this is like this
see how
group
they're both on this, like they're on the same side? So imagine, see that carbon next to it, the one that isn't attached?
That one?
To the right of that?
That one?
See how it's going up?
Yeah.
Now imagine that being on that other end of that double bond. Instead of it going downwards, going upwards.
Okay.
So like use your cursor to like kind of like show me like left of that card.
This one?
Yeah, imagine it going upwards.
So there's a hydrogen going up here and there's a hydrogen up here, right?
Oh yeah. But imagine the carbon goes upwards. Then it would be Z.
No, I see what you're saying. So like both of these, the hydrogen's pointing upwards, and these are both on. So that makes this side chain and this side chain on the same side. So if this one was flipped over, the hydrogen would be here and here.
Wait, say that again?
So like if this side chain here was like flipped,
yes,
there would be a hydrogen pointing away and then one up this, so it would just be opposite. Yeah.
Yeah, then it would be E.
Yeah, I think I see
they're
that
both
now.
like on in that same like direction pointing downwards.
That was something just little that I missed, and like I kind of get bad testing anxiety when I see all this crap at once.
It's designed to psych you out. So
no, for sure. And I never saw anything like this in like undergrad. Like I had some pretty brutal biochem tests.
Yeah.
But at the end of the day, I was regurgitating the information I learned. I wasn't really been asked to think. That was never the case in any of my classes.
Yeah, it's meant to be like that because again, they're from like like a Nature publication. You know what I mean when I say that? Like something like from like a like some research article.
For sure.
All right.
This one I got right away.
Diols, okay.
Yeah.
Okay,
this one's pretty obvious. Because it said diol, so I knew it was 2 alcohols, and then I think I just looked at them all and I was like, okay, well, carbon 6 and 7 here. I just figured out that the alcohols would be there, I guess. Like, I didn't like really know any more than that, but I don't think I would have a hard time with that. Like, I think I figured it out. Like,
yeah, it's so like right away you'd be able to cross out the first one because that's not really a diol. It's not really.
And I knew D. Yeah, I crossed out D when I took it too right away because.
Oh yeah, because they're further away. I guess
it didn't make any sense.
The third one could be a little tricky, but it's that epoxide that forms. So it's like a syn addition. Yeah.
Okay, cool. All right, so this is an example of me making a dumb mistake and losing a question over it. Like, I think I was just getting overwhelmed, and it was like which epoxide carbon is attacked by the carbonyl of the keto epoxide. Like I was just kind of getting overwhelmed by that, and I knew to look here. Actually, I looked here first, and I was getting a little overwhelmed.
Yeah.
And it said at position 8, and I don't know if that just threw me off, but like I knew it was 6 or 7. I don't know why I picked 7. Like it made, after reading the explanation, I think 6 made more sense, but like I don't know, just trying to catch myself and like work through it. I think like the solution, they said something about epox. Oh wait, never mind. That's for another question after this. But yeah, like this is an example of like classic something I just missed, that like I was 50-50 and made like a bad decision.
So all right, so let's see. So it can be either on the 6th position or the 7th position, and they're saying that it's gonna make that carbonyl carbon at the 8th position. Wait, let's see. The 8 one, okay. And that weird one that, wait. Okay. Alright, the 8th position seems to be part of this chair structure over here. Like figure 1.
Yeah, right here.
Yeah. See how like if you like go down and to the right and down again, it makes a chair. You know what I mean by chair?
Yeah.
Yeah. So it seems like it makes this like cyclohexane kind of thing.
Yeah.
And so okay. So let's see.
Yeah, like the way that I think they were saying it was just kind of confusing. Like they were acting like I think the bond would have been longer had I done it at 7 instead of 6. Like,
yeah, it seems like it bonds on itself. So that carbonyl, I think something turns like positive, and then it attaches and closes that ring.
So like this is a situation where like my orgo's not like super sharp. Like I knew it was one of those two, and I went with the like worst answer. Like if you saw something like this and you were taking it, like I don't know, like what would you like guess? Like I mean, seeing it now, I see 6 as a better. That probably made more sense, but I don't know.
Well, right away, it's good that you're able to break it down to 50-50. But taking a look at it, like I would draw like, since we know that there's a ring closure, I would draw like either an arrow from like the C6 to that carbonyl group, or from the C7 to the carbonyl group, and see like how long that or how big that ring is. So if I did it from the C6, I would get 1, 2, 3, 4, then 5 for that, and then C7 I would get this. Because they're basically asking which of the carbons attacks that carbonyl. Like, you know how carbonyls have like a partial positive and a partial like negative charge?
Yeah.
Here, I'm gonna draw that. Okay, if that goes there. 1, 2, 3, 4. Oh, I get it. Okay, so if you connect, here, let's see what I can do. If you draw like an arrow from C6 to the carbonyl carbon, and you can count the number of carbons in between, and then count the oxygen as well because it's part of that ring, then it turns into like a 6 carbon structure, but one of the oxygens is or 5 carbons with one being an oxygen, so it basically forms like, let's see. Alright, so here, let me share my screen for a sec. Oh wait, let me open up whiteboard. Okay, I'm gonna share my screen. Do you see it?
Do I have to click stop share or?
It's weird because I have it so multiple people can share at the same time, but for some reason I don't think it comes up. So yeah, hit stop share for a sec.
Okay, I see yours. Yeah.
Well, actually, I just realized drawing those numbers will just make it more confusing. But basically, they're just asking like when, like, is it going to be this guy or this guy that attacks that carbonyl carbon? When it attacks, it's basically going to produce this thing over here, and then like this will be like minus for a sec, and then when this epoxide opens up, it's going to leave like like a positive charge basically on one of them, which will attach back to the negatively charged oxygen. So basically, all right, without drawing all this, like I think the drawing looked something like, was it something like this? Wait. All right, I forgot what that drawing looked like, but I know that it was part of like a wait, it looked like a chair, so something like. It was something like that, right? I don't remember if there was like one carbon or not, but I know that this, or oh, maybe there was like an oxygen there or something. But anyway, they're just asking which carbon, is it this one or this one, that will produce something like this. And since this is a chair, like it's basically like this over here. So that's 1, 2, 3, 4, 5 carbons. So, it's gonna basically, so if it's this one that attacks this one, there's 1, 2, 3, 4, 1, 2, 3, 4, 5 carbons in between, including this oxygen. It should form this over here. Whereas if it forms this, there's going to be like an extra, like a carbon group there. So maybe like some type of like heptane or something like that.
Okay.
But basically what's happening is like a ring opens and then or an epoxide opens and then this ring closes, and you just have to count, I guess, the number of carbons that are between like the carbonyl and the carbon that they're asking you is the one that attacks it.
Gotcha. Yeah, I've seen a few questions kind of like that before, and usually you have to like count in between. Like visually, I would not like write all that out.
Yeah. Just from looking at it, I would just like look at it and then count like how many are in between, for each of these, and then you can like look at that the end result.
Okay. Yeah. And like let me share my screen again. Where'd I go? Oh, there we are. And like they said to produce this outcome, are they talking about the product or?
Yeah. They're saying the 6S7R isomer. So if the keto epoxide intermediate is the 6S7R isomer.
I wonder if I could just even looked and saw I see this is a 6-membered ring, right?
Mm-hmm.
I don't know, I'm not trying to overthink this question at all, but
yeah, so that 6-membered ring, that chair structure, that is what forms from that epoxide closing in on it.
Oh wait, no, I see. Yeah, I see it now. So if it had attacked the 7-carbon ring, then it would have formed a 7-carbon. I mean, if it attacked the position 7, it would have formed 7-carbon. All right, I see. I kind of see that now.
Mm-hmm.
All right. This question I got wrong because this is what I was trying to talk about.
Yeah.
I guess with the epoxides, I was maybe supposed to know that it wasn't going to be these two positions here, one away and one up.
Mm-hmm.
I didn't like content wise know that. So that's why I immediately got it wrong.
Yeah.
Um, and I don't know if that's just a special case situation or.
Uh-huh. It seems like I guess what you're looking at is 6R 7S, and so they're like in different, you know, directions. Like one is like whatever clockwise, the other is counterclockwise. So maybe that's why you chose like the ones that are different.
Yeah, maybe so. I don't know. Flashbacks to Orgo. Don't really exactly remember that. But then I reviewed this one and I remember I know the rules for now for figuring out. I was a little confused though. Like if I'm going through the like, say I'm looking at this carbon here, I know that the H is for. I know that this oxygen here is going to be number one, and I was a little confused. I guess if I'm looking at this molecule here
Yeah.
or this carbon, I mean. This one is this carbon here is higher priority than this side, and
Yeah.
I thought it had to do with like atomic weight or whatever. But I
Uh,
guess I was supposed to see that the carbon was closer to the oxygen, and then that ethyl group. I don't know.
yeah. That's the thing. If it wasn't attached to that oxygen, it'll just be attached to like the ethyl group, whereas the
So I
other
should
one is
look for like
also.
an atom. Sorry, go ahead.
Oh, wait, say that again.
So I should look for like if I'm between two like groups, right?
Yeah.
Like I should look for whatever the biggest molecular weight as far as like oxygen, nitrogen, whatever it is that's closer to the carbon adjacent.
Yeah, or if it's just attached to like different types of like if it's attached to like a carbon that's attached to some other stuff, like look at that weight, the weight of like the
Okay.
carbon that it's attached to.
Yeah, I just definitely was getting this wrong. So like I didn't know. I guess the I don't know what the word I'm looking for is like this like the spatialness of like whether they were up or away towards whatever.
Yeah, it's pretty weird because they're basically saying that the H's are pointing like into the paper, but they don't really show anything pointing out. Because
Yeah,
the
'cause I
lines
know there's a
are.
lot of molecules that's like this.
Yeah.
Like I guess like I said, I know Altius tends to be a little bit more like difficult,
Mm-hmm.
but like when I did take it, honestly, like when I did take the last MCAT, it was a pretty tough section.
Mm-hmm.
That I feel like was more akin to the Altius test than some of their own like exams.
Yeah.
Um,
Yeah, Altius and yeah, next step they're definitely going to be harder than the AAMC stuff. So far, just looking at this Altius stuff, it's definitely a lot more like organic chem than what I normally see.
yeah.
Are there like
I
any
definitely.
yeah,
Sorry,
any
go ahead.
types of like problems in particular that aren't like necessarily content, but like, you know, like math or anything like that? That like
I don't know like exactly like I definitely know when I'm getting things wrong, I get more questions wrong under that data analysis and the SIR2 like the
Mhm.
I can't remember what that one is under. It's
Okay.
usually less content. Like this one I got wrong. I eliminated two right away and I got it wrong. Like I just wasn't sure what to do here. Like
Okay.
I guess you need to know what the prodrugs were, which I know what a prodrug is, but like still like I didn't know where to go here.
Okay, so it seems like for this, we're going to look at the passage because they're saying which experiment, so they're referring to, like, you know, an experiment that they've done, right? And then, here, let me check out that question again. So they're saying which experiment would be the most useful in determining whether or not phenoso-naphthol glycosides could serve as effective prodrugs. Wait, so, all right, tell me what a prodrug is.
Um, it it's basically like it's basically you have a drug that's and it's an active form and
Yeah.
like you cleave something off, you make it active. Yeah.
Good. Also, like, if it's an enzyme, it's going to be a zymogen.
Yeah. Yeah.
Good. So, all right. So let's see. Now let's look. Beta. Wait. Okay. So beta glyc. Okay. There's some type of thing. They affect. All right. So I'm basically just doing like a control F in my head to look for that pheno thing. I think I see it. Oh wait, neither of these pheno blah 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 glycosides induced false positives. So I see. So basically, so they're basically trying to recreate that enzyme, and they add this phen azopthol. Basically, like they basically add this phenol like group to it. Because I'm just looking at like the pictures above and then the pictures below, they add that benzene ring with that NH like 2 group on it.
Yeah, I was like ignoring the pictures because they were kind of complicated, and I was like trying to use the words.
Yeah, if you like, I know it certainly is complicated because they go into like mechanisms and such. But if you like look at like if you try to look at it like super simple, scroll up so you can see like both, like I guess like figure 1 and figure 2. So like figure 1 and figure 2,
where do you want me to look?
They look kind of the same, but like there's a big difference, right? Like mostly in just that benzene ring.
Oh, are you talking about just figure 1? Or are you talking about figure 2 as well?
Oh yeah, I'm talking about figure 1 and figure 2.
Okay.
Like what is the major difference between the two? Like without like looking at it too closely.
Yeah, like, I guess I'm looking at obviously the benzene rings.
Yep.
Yeah.
Yeah. So that's what I noticed. So it seems like and the phen azopthol thing or whatever. I just looked at the PHEN, which means benzene, right?
Okay.
Like phenylalanine is like a benzene, you know. So okay. So I it seems like the they try to make some type of drug using like the beta galactosidase whatever thing above, but they add like the benzene ring to it. Does that make sense, that part?
Yeah, I think a little bit. And I think I got rid of B and C right away. I guess I was somehow trying to associate the chemical structure as a good answer. I don't know why, like that threw me into it. And I was like between that and then UV spectroscopy as like a way to measure it. And I guess that I should have picked up on that. Nothing. I guess because I saw. Well, I think it's because I saw the structural change.
Yeah. So think about it like this: like, if it's a prodrug, right? It's going to be in some form, like where it's inactive, right? And some form where it's active. So you basically just need, like, without knowing any details, you basically just need a way to measure or find its active form and its inactive form.
Okay, so the UV spectroscopy would have basically been able to allow you to see the two different changes to it after it's cleaved.
Exactly.
Versus the reactive. That makes more sense. All right, that makes more sense. I was on the right idea with the structural, like seeing the difference, but we weren't altering anything to test its reactivity with the beta glycosides had nothing to do with it, basically.
Let's see. Alter the chemical structure of the phen. All right, and test its reactivity. I think I think you're on the right track in thinking that we're altering the chemical structure of the beta galactosidase, because we're adding that phenyl blah 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 thing to it, but we're not changing the phenyl blah 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 thing.
Okay.
But I see, like, you know, I can see why you chose that.
And I wasn't well. I see now here. I didn't read the passage super in depth. It was kind of a convoluted one, but I see UV.
It certainly is. I didn't even like really.
I didn't highlight or anything, but like I should have tried to skim through it and see if I could find anything. Maybe if you saw something like that, would you maybe try to skim? Because like I see here now, substrate and product were both detectable via UV spectra. I mean, that makes more sense. Like that would have led me more to that answer if I'd seen that.
Because it would lead you to choose something that would say UV spectroscopy, or because they said substrate and...
Because it said they were detectable.
Yep. Okay. Oh, I see. And then I guess the only choice that says UV spectroscopy is that?
Yeah.
Yeah. That's good to notice, but let's say all of them said UV spectroscopy, like let's say like B, it says measure the activity of just, the phenyl blah 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 thing. I keep saying blah 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 thing, but and then C says lactose, I guess, with just beta glycosidases. You just really just need an answer that says how it performs in its prodrug state and how it performs when it's not a prodrug state.
Okay. Yeah, I tend to overthink these types of questions like that.
But yes, the fact that you can detect it with UV spectroscopy, of course, is going to be the experimental thing that you use.
This is an example of me like having math issues. Like I didn't have that formula memorized, and I knew it wasn't this one and this one. So that seems stupid, but I didn't, I guess, pick up on this part.
Let's see. If an x-axis acceleration of a and a y-axis acceleration of 2a are each maintained for exactly 1 second, how will the distance traveled in the x direction compared to the distance traveled in the y direction? Okay, so you can kind of just I don't really. Well, they're saying to use a formula, but I would just think of just drawing like the two vectors, like a this way, 2a this way. And let's see, how would the x1 compare to? Yeah, so actually I don't know why they tell you to use that equation. So I just the fact that if you just draw like a vector, right, for acceleration, and x is equal to a, and then a vector for acceleration in the y direction, that's 2a, right? So if x is equal to a and y is equal to 2a, we can cancel out the a's, and here I'll write this. So if x I would just write x is equal to a, y is equal to 2a, and then I can just basically just write x is equal, x is just half of y then, right?
Oh, I see. Yeah, I see that now. See, I see these kinds of relationship ones, and I start to freak out. I'm like, I don't remember a formula.
Don't let that get to you. They're you don't have to know that kinematics equation at all to answer this. They're just really telling you just try to do it like a.
So they're just like x is this, y is this, what's x, and it's just 1/2. Yeah, that's okay. That's pretty easy. That kind of stuff overwhelms me. And I'm like.
They want you to feel like you need to know the equation and stuff, but I don't even know why they say that in the explanation. You don't need to use that kinematics equation at all.
Yeah, and this is another example of when I got wrong. I think I didn't remember the capacitance formula. I knew the V is IR one, and I knew they were similar, but I wasn't sure. I didn't know the formula here.
Okay. Yeah, capacitors can get pretty. I would say it's one of the more difficult stuff within the umbrella of physics that they ask you. But what helps me memorize or know formulas is knowing the units, and if you know the units, it'll help you figure out the formula as well. So capacitance, for example, is charge per charge per volt, but volt is really just joules per coulomb. All right, let's see. So the IC3 stores a small amount of energy by charging an integrated capacitor using direct current from the transducer. If the transducer produces a voltage V and the capacitor has a capacitance of C, which expression gives the charge stored on the capacitor? Okay, so
I knew charge was Q, but I couldn't remember what the formula that was. Yeah.
Tell me that again.
Yeah, I knew charge was Q. I was thinking of that one equation. I can't remember. It's the Q1 Q2 over R squared or whatever.
Mm-hmm.
I don't know. I just didn't remember. I didn't remember the capacitor formula, I guess. But like,
Oh,
is this one I like would have to memorize like Q with CV?
let's see. Okay, um, okay. So voltage, think of voltage as, or a volt as being like energy per charge. So like joules per coulomb.
Okay.
And capacitance, right? That's basically going to be um, joules per, or no, rather. Oh wait, they're just asking you to solve for the charge. Okay, so wait, sorry. I mixed up the C with coulombs for a second. Okay, so basically, alright, so capacitance is basically the amount of charge you can store in on a plate basically. So alright, so that
Okay. Yeah.
equation basically C is equal to Q over V, the amount of charge stored per volt. Yeah, you should yeah, you do have to know that one. But all right, let me think of how to make this easier. So capacitance, volt is joules per coulomb. So a farad basically. Sorry. One sec. I mean, you end up getting like coulombs squared over joules, but basically, all right. The best way I can put it is just to think of capacitance as the amount of charge stored per volt. Do they have like a diagram of a capacitor or anything like that?
I don't think they did.
Okay, so you know what like a capacitor looks like, right? It's just
Yeah, I
like
know what they look like. Yeah.
so basically you're having electrons like moving from a battery to
Yeah.
the to one plate of the capacitor, right?
Yeah.
And so that capacitor is starting to gain electrons, so it's starting to gain a charge. And since it's basically it's basically it's going to gain that charge until it like reaches the maximum amount. So I guess just for this one, like that is a formula you should know, because
Yeah, that's a common formula. Like I honestly just haven't seen it come up that much. Like I see
yeah,
the other one, the voltage formula comes up more.
the voltage
The V is IR, like the resistance.
Oh yes,
Current.
yes.
That one. Yeah, that one I have memorized. That one comes up a lot.
Yeah, I would just say to just all remember or just to remember that capacitance is the amount of charge stored per volt. Like if you don't remember capacitance is equal to Q over V, try to remember that it's equal to basically like coulombs over volts.
Yeah, the way you said that made more sense. Just go, it's charge per volt. That makes more
Yeah.
sense. I mean, like just knowing that, I would have gotten it. Yeah. Okay.
Mm-hmm.
And then it was just basic algebra to move it around. That was pretty simple.
Yep.
That's just knowing something. This one I knew. Yeah, this was an example right here of me just making another like mistake again. Like I didn't see that it wasn't like I was kind of rushing and I didn't see that it wasn't chiral.
Mm-hmm.
And that's yeah. So I'm having like those situations come up a lot where I'm just like, I don't know. it was just
Yeah.
test anxiety or what. Like,
Was there one that you thought was chiral, like maybe the nitrogen or something?
I think that I was so like distracted by the question that at the
Yeah.
time when I was going through it, I wasn't thinking real quick to like look through that to see if one of the carbons was chiral.
Okay.
Um, yeah.
Got it.
This one right here, I had a little trouble with. Like, I set up they gave you the formula in the passage.
Yeah, that's the
And the
Henderson
reason,
Hasselbach.
yeah, and I actually got it right guessing just because of doing enough of these. Like, I knew it wasn't gonna, like, I didn't think it was gonna be this large numbers. Like, it
Okay.
usually isn't that big. Not that it would be that obvious all the time, because I
Yeah.
solved for it and I couldn't figure out what to do with the Ka. You're supposed to convert to pKa, and I did not know how to do that.
Okay.
Um,
So anything that has a little p in front of it, you just take to the power so okay, like pH. Here, I'm gonna do this because this will let me. All right, so I'm gonna screenshot this question here. I'm gonna paste it into the whiteboard, and I'll share my screen.
all right.
Okay, so basically, all right, so pH corresponds to negative log of the H plus concentration, right? Sorry.
Yeah.
So the H plus concentration is 10 to the power of negative pH. Because logs are essentially just like the inverse of an exponent, and if the log is a base of 10, 10 is going to be the number that you raise, the other thing to. Like for instance, like log of x is equal to, I don't know, a, and that's like a little base 10 over there. So basically it's, you got to ask yourself to solve this, 10 to the a power equals x. Sorry if the a looks like a 9.
No, you're good.
Yeah. So for, this, like pretend that there's like a little 10 there, right? 10 to the pH power equals H plus concentration. Here, I'll try to do it like this. And it's a negative log, so that's why there's a negative part. So just like, log of x is equal to a, it's 10 to the a power is equal to x. For here, it's still like a 10 there, so 10 to the pH power is equal to h plus. There's a negative just because it's a negative log. So let's try one. So like, what do you think the log of 0 would be? Like 10 to 10 to the power of what?
I think it's 1, right?
Oh wait, sorry, not 0. my bad. I should have said 1. But all right, no, forget that. Let's do. Damn it. Sorry. I'll just do something like easier like that.
Yeah, it's an example where like I was just in chemistry class using my calculator.
Yeah. No, I was like writing down 0 and 1 before because I was thinking of 10 to the power of, but then I was like, wait, I'm doing like base. 10 is the base. So okay, this is going to be better. So this way, like, try this thing again. So like 10 to what power equals 100?
This is second power 10 times 100, so it's a 2, right? So it's second power.
Yep.
Okay.
Yeah. So yeah, if you just like remember like this is the way to do logarithm, like take that base, whatever it's equal to, you take it to that power and it'll equal to whatever that part is.
Okay.
So a pH, like this, you've seen this before, right? pH is equal
Yeah,
to...
I'm comfortable working with that. Yeah.
Okay, yeah. So now that is true for every like little p thing, right? So like pKa is going to be just here. I should write it like this. Oops. pKa, that's going to be equal to negative log of Ka. And so basically, to get Ka, what would we do? So just like here, right? We got that. To get Ka here, what do we do?
Hold on, like let's step back for a second. So
Yeah.
they gave us the Ka, right?
Mm-hmm.
And we're trying to go to pKa, so we would take the negative log of the K that they gave us to
Yeah.
get pK.
Yeah. So like how can we do that, without doing like, like just like here, instead of doing the negative log, we just did this. Because of that over there. Like the 10 to the power of pH gives you the H plus concentration. And it's just negative because it's a negative log. So just like that, for this, here maybe that 10 there would help. That 10, right? To the power of this, pKa, will give you the Ka. Just try to think of like that. So
Yeah, they put a number, like I would be able to follow like
okay, oh, all right, okay.
Yeah.
So let's see. Okay, they give us a Ka value. But all right, I'm just going to quickly write it'll be 10 to the negative pKa
Okay.
power. Okay. Now I'll also show you another shortcut for doing like logarithms, or rather like negative log of something, like if they give you like a concentration. So like let's say that you have something like well, I'll just use what they give us. So they give us a Ka of 9.9. So instead of doing times 10 to the something power, I just like to write like for shorthand, kind of like exactly what your calculator would say. I just use capital E.
Oh yeah. Okay.
-7. And then, so if you want to find the pKa of this, you basically take this number over here and you subtract it by the log of this number. So this is going to equal 7 minus log of 9.9. So if you had like something like 4 times 10 to the 7th power, and as, let's say, your whatever Ka, your pKa will be 7 minus log of 4.
Okay. All right.
Yeah. Now 9.9 is pretty annoying, so I would just turn that into a 10. And I would get 7 minus log of 10. And what do you think log of 10 would be?
Is that just 1? Is that you do the
Mm-hmm.
right thing? Yeah. Okay.
Yeah, because
So
10 to the first power is equal to 1, right?
10. Oh, yeah.
So then
1.
this should just give you 7 minus 1, or 6.
Okay.
So, oh, and then that's going to be the...
So that'd be the pKa, right?
Oh, wait. Sorry. That is if they gave you the pKa. I did it like kind of like backwards if they gave you the pKa, but they gave you the Ka. So we're actually going to do the thing where we take 10 and we take it to the power of that. Oh, wait. No, what am I talking about? Sorry. I did not mean to confuse you. Let me put this all back. Sorry. Yes, this is the pKa.
Okay, so for a log of 4, would it be... How do I do that one?
Oh, okay. So
We have to memorize certain values? Or...
Yeah, so I basically... Yeah, I'll share like this like document, like I'll make like a OneNote notebook for you, so I have...
Okay, cool.
Like, here. Yeah, I have like math stuff to like memorize, like right here. Like log of 2, log of 3, log of 5, and log of 7. If you know those, you can basically solve for any... You can solve any log. Like, log of 2 is equal to 0.3. So log of 4, we can rewrite as log of 2 times 2, which is going to be log of 2 plus log of 2, which will be 0.3 plus 0.3, which is 0.6. So this would be 6.4. Sorry, that didn't show all of it. Yeah. So here, I'm going to move this over a bit so we can like do it with some space. So let's like look at it brand new. So I would first draw... Okay, they said the bicarbonate concentration is 26 millimolar, right? And so I would write bicarbonate concentration is equal to... we'll just do this, 26 E negative 3 molar. Now, why do you think I wrote it like that?
To make it faster to solve, like convert everything over.
Yeah, because Yeah, that way I don't have millimolar. I just
So
have molar.
if it's milli, it's to the -3. If it's micros, it's to the -6.
Oh yeah, yeah,
Okay, I'm trying to remember all that
yeah,
stuff, math.
yeah.
Yeah, okay.
And it seems like the answer choices are all in millimolar anyway.
Oh yeah, so we went. Okay, yeah.
But I want to see if 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 it matters or not. So let's see. They're asking us. Okay, they say. Sorry. Okay, and then they tell us the pH is equal to 7, or rather the pH that we want it to be is 7, right? And the Ka is, I'll just write 10e -7. So the pKa will be 7 minus log of 10, which is 6.
Okay, yeah.
And then I can just plug everything into the so that's the Henderson Hasselbach equation.
Yeah.
And when you if you take the log of something divided by another thing, it's the same thing as subtracting them.
Okay.
Yeah, so I'll share like this stuff with you. Wait, that's like here, like logarithm rules. So like if you take the log of like a product, like x times y, that turns out to be like additive, log of x plus log of y. And if it's something that you divide by something, like if you take the log of x divided by y, then you subtract those two logs.
Okay.
So this over here, like, it's log of the bicarbonate concentration divided by the I guess carbonic acid concentration, right?
Yeah.
So here, log of this divided by that is the same as log of this minus log of that. Sorry. It's, yeah.
Okay.
Does that make sense?
I mean, I've not seen that before, but I mean that makes sense.
Yeah, because it's just it's a log of a quotient.
Fraction. Yeah. Cool. Okay.
Yeah.
That's
So
kind of helpful because like I didn't know that. All right.
yeah,
I mean, I've seen it in algebra, but like that was a long time ago.
yeah, I'm gonna share this with you where I go over this at length. The math
Cool.
stuff is very, very, very useful. So basically, like if we do it like that, we basically have values for everything, right? And then we can just rearrange it, like algebraically, and solve
Make
for
it easier to rearrange
that
too.
right there, right?
Yeah.
Wait,
Okay.
what were you saying?
So that makes it kind of easier to move stuff around too. Like.
Oh yeah, because otherwise you really can't, because like you would have log of something here that you know, and then something here that you don't know, right?
Wasn't there like a situation where they say it like cancels out or like to ignore it? Maybe I can't remember.
Oh yeah, if they have the same value, like at equilibrium.
Yeah.
If they have the same value, then this divided by this would be 1, and log of 1 is 0, and then pH will equal pKa. So that's like if it's a strong acid, right, and it dissociates completely.
Yeah.
Yeah. Now, if it's a weak acid, that'll give you a different concentration of, acid and conjugate base. And so it'll be like something that is not equal to the pKa. Like it'll adjust the pKa a little bit. So, all right. Now, okay, so we have the pKa, right? And we add it to this over here. And we set it equal to a pH of 7. So I'll write this again. pH is equal to pKa plus log of this all right.
Yep.
And in place of this, I'm going to write, this over here. Right?
Yep.
All right, and since I want to solve for this concentration, I can add this on this side, and I can subtract the pH as well.
Okay.
So I would get log of that Does that make sense?
Yeah, I'm following.
Okay. And then, then I'll plug in the values. So I get 6 plus, all right, since this is, this concentration is this, I would do, 3 minus log of 26. 26 is kind of annoying to do. I can just do, 30 instead.
Okay.
So here, let me do, the log of that right there. Or rather, sorry, wait. Yeah, log. Oh, yeah, wait. It's a positive log. So it's a positive log, so I'm not doing the thing where I subtract it. I'm just going to add it. And 30 is the same as 3 times 10. And the... and log of 3 is 1/2. Sorry. Wait a sec. All right, I'm gonna look at the choice to see what they did. I want to see if they're doing it the same way. They're telling me to, okay, we did that. We got 6, okay. 7 equals 6. Oh, I see what they did. All right, okay. So what they did, actually, we can do to make it faster. But what they did will only work for this situation.
Okay.
So, all right, I'll make a OneNote notebook with you, and I'll show you how to do the full math for all of this. But for this one, you can solve just for this situation since it's equal to 1. Okay, so this is what they did. So, here, I'll do it. I'll write it on top. So since all right, pH. Okay, so 7 is equal to 6 plus log of HCO3 minus over H2CO3. And you subtract 6 on both sides, you get 1 is equal to log of this crap.
Yep.
Right? So that means that this has to equal 10. Like the thing inside of this log has to equal 10, right? Because log of 10 is equal to 1.
Okay.
Yeah. So if the bicarbonate is this, so since this is on the top, like the 26 millimolar is on the top, we need to figure out what do you divide it by in order to make it 10. So here, I'll write that in blue. So basically 26 millimolar over X is equal to 10. Right?
Okay.
And so if you solve for X, 26 millimolar over 10 is equal to X.
Okay.
And 26 divided by 10 is 2.6.
Okay.
And that's your carbonic acid concentration.
Okay.
Yeah. So just because it happens to be equal to 1, and we know that log of 10 is equal to 1, means that we can solve this problem doing it this way.
Yeah.
Yeah.
They probably wouldn't give me one any worse.
They probably wouldn't, actually.
Yeah. I know all TS calculations can sometimes be kind of rough.
Yeah.
Like, it's good to know, like...
Yeah, it's good because we got through a lot of, like, logarithm material in the process.
Yeah, that's where I struggle the most with, just because I always use my calculator. I always use my calculator for physics.
I'll share and go over, like, all this logarithm stuff with you. Because I even go over, like, why use them, stuff like that.
Okay.
But
so, like, definitely this is mainly the struggle is the math calculations, second guessing myself on answers. Like, I mean, going through it, like, I feel like I know the content pretty okay, like, for the most part. Like, I can talk through some of it. I just am having a hard time. That's why I've been doing more practice tests. I took two practice tests last week. I've only done one this week. And, like, I've not seen a drastic score increase yet.
Yeah. Here, you can share your screen and show me some more, like, math type problems.
How much longer can we work together? Do you have today?
Oh yeah, I mean as much as you want.
Cool. Yeah. Yeah. I definitely need to work with the math stuff. It's an issue for sure. So this one I got wrong, and like I know some of this stuff, but like they always find ways for me to get like caught up and like second guess myself. But like it was like asking about carbonic anhydrase is named after which reaction, and I was looking at it and I knew.
It says above that the enzyme carbonic anhydrase catalyzes the aqueous equilibrium between carbonic acid, water, and carbon dioxide. So look for the one.
I didn't even read that. I was just trying to answer it by looking at the equation, which I recognize. I don't know why I recognized that one right away. I don't know why.
Oh, I think just because that's what happens in your blood. Well,
yeah,
all of this
like I knew that, and then like in the heat of the moment, I guess like oh crap, what do I do?
Yeah. Like all of this happens, but like that's what happens.
Like I knew it was reaction one, but the answer was reverse of reaction one because I didn't realize like just not thinking like hydrase as like when you add water, but it was saying I think it had to do with the reverse of the reaction because like I get myself confused now. Hold on. No, it was talking about reaction one. All right, now I'm getting myself confused again. Yeah, like this one was kind of tricky.
Yeah. So let's say so basically the all of those three reactions are involved. So like carbon dioxide, like let's say you're not breathing as much, hypoventilating.
Yeah.
So more carbon dioxide is in you, and it mixes with the water that's also in your in your blood essentially, and it creates the carbonic acid, the H2CO3. And H2CO3, when it interacts with water, it's going to release, since it's an acid, it's going to release H plus, which is like the hydronium ion thing, the H3O plus.
Yep.
And then the bicarbonate is the conjugate base right there. And then I guess Roman numeral 3 is just the CO2 that's aqueous, that's dissolved in water, aka in your blood plasma, um, eventually leaves as gas. But okay, so I guess the question is, how do you know it? All right, so you were able to know it was reaction one, so okay, good. But how do you know it's the reverse or not?
Yeah, I was kind of guessing on that. Like,
Yeah,
I
so
was a little lost with
I
like
would think
what
of
to do.
yeah,
Yeah.
I would think of like hydrase. Seems like you're adding water, and anhydrase is like the opposite. But actually, there's no other way to really like get that to solve that one.
Yeah, that was pretty much
You
a
kind of just
discrete,
have
like,
yeah. I'm trying to yeah. I mean like I'm just like, answering it the way I would, which is just like hydrase means to add water, anhydrase probably means the opposite. Yeah, I guess that's just good to know. Also, like an anhydride.
well, I guess like they're saying like a hydrase is adding water, which is
Yeah,
obviously what they did in this one. They did that in this one and this one. But they're saying an anhydrase is the opposite, so it's removing water.
yeah. Have you
So
ever?
it's kind of like a it's kind of like a what do you call it? Not dehydrate. What's the other way of
Yeah,
saying it? Yeah.
yeah. That's it. Dehydration synthesis.
Yeah.
Yeah.
Yeah, like I kind of like know some of this, and it's just hard in the moment to actually like execute it.
Mm-hmm.
Um, and like also like I'm having issues with timing. Like I'm getting better about it just because I always get anxious about getting stuff wrong, so I get mad and I rage quit. But
Yeah.
do you like at a certain point like
I think
I'm trying to should
it's
I just like
good.
mark stuff and just move on? Like if I'm
Yes,
like
yes. If anything is taking, like, I mark, like, I flag liberally. Like, if anything takes, like, too long or requires you to do too much work or to read too much in the passage, like, since every single question is worth the same amount of points and not every single question is the same difficulty, I would just flag it and move on. Ideally, you want to, you want to see at least every question and still have time left, and then you can go back and answer the ones that you can answer. But if the ones are taking too long, yeah, like definitely flag them. And also, I think it's good to start off like without it being timed, so you can kind of like spend time like trying to like actually figuring it out. Because if you're doing like everything like timed at first, you never get a chance to even attempt some of the questions, and you get the answer right away, and then it kind of like makes you think like, I have the answer now, I'll get it right next time. But like I personally just think it's better to like spend as much time as needed for you to understand something, because there's a lot of like intangible stuff that you learn in between that you can actually apply to other things in the future.
yeah, sure.
Like I would spend like a ton of time on like a single problem, just so I would get it right like on my own. And people would always say like, that's not like high yield, or like that's not like a good use of your time, but I think it's like the best use in my opinion. Of course that depends on how much time you have until your test. So as your test gets closer, then we can start worrying about time, and after that point it's like an endurance thing. But at least you have like the foundation stuff down.
Yeah, I feel like 'cause I had issues like when I press like start on the test, like that's where the anxiety kicks in, and it's like really tough for me. Like if I had unlimited time, I do a lot better. But obviously, I don't have that luxury now, so that's why I've tried to start like speeding it up and kind of get used to test mode, because that was a lot of the problem last time. Like I dropped 5 or 6 points last time because of
Yeah.
that. So I've been
So
working on that.
since you are doing it timed, like the ones that you get wrong that you haven't had a chance to attempt, try to there's no way to like see which ones you got wrong without it telling you the answer, right?
Yeah.
Like is there a way?
I mean, I guess I could do a retake because like I
Yeah,
think I
but
have
okay. So,
like I could open one up. I probably have enough
oh,
attempts in
have you done
them.
the
I could,
section banks for like the AAMC section banks?
yeah, I did them last year, but I've been doing them again.
Okay, you could do those
I'm about
without
halfway
without it
through.
being timed.
Yeah, I've been going through those. I think some of them are a little bit easier than these.
Yeah. Oh yeah, they're all going to be easier because Altius and yeah, next step
Yeah,
they're
for sure.
definitely
Like
harder.
I've not gotten higher than 125 so far on their psych soc, but like the last AMC one I got a 129. So um,
Yeah.
I'm just learning from them. I don't think their psych soc is quite as much like the AMC, but and I'm just using their cars to get used to the timing. I'm not really trying to learn from it that much.
Yeah.
But I think that their bio and their chem's good because it is really tough, and I'm learning a lot from it. So
Yeah. Yeah. I think that's like the best use of Altius and next step because yeah.
like some of this stuff I kind of know. That this was kind of a tougher. Like I've seen some of the stuff with AMC
Oh yeah.
before, but I feel
So
like
this
they
is
get
kind
more
of what I was
used.
talking about before, right?
Yeah,
When I said that log value turns into a zero.
yeah. This was I did not. This is an example of like I constantly have issues with these types of. Some of them I understand if like I know the formula really well, but I have issues like
Mm-hmm.
with this type of a question, like ratios,
Yeah.
and which one's like the right formula or way to express it. Like,
Yeah. So yeah, knowing like how to express things in ratios is like one of the like biggest like strengths you can have because you can. So okay, like let me ask you this. So, what would that log? Okay, so if the the one that you chose, the bicarbonate solution is greater than the carbonic acid solution, that would produce a log value that is basically greater than zero, right?
yeah, so I wasn't like this is yeah, I wasn't even like looking at that. I was like, oh crap, what do I need to know about the formula?
Mm-hmm.
Huh. So this is like a situation where I would look over here at this and I would be like, if this number is greater than this number,
Yeah.
I would need to like, what would I? How would I figure this out? Would I need to like mentally like plug something in my head,
Um.
like a number or like?
So like I know you said that it's easier for you to understand if you do plug in numbers, but if you understand it like algebraically without the numbers,
Yeah.
you can kind of see like the principles behind it in a way. So like let me see. So basically if you're taking a log of something that is like okay, so log of 1 is like I'll just share this with you. Like okay, so like what do you remember about logarithms?
Um, it's a function of my calculator.
Yeah. Okay. So so I'll share this with you like right after our session. So basically, if you take the logarithm of a number that is smaller than 1, that logarithm is going to be negative.
Okay.
So in that so let's say that the carbonic acid solution H2CO3 is greater than the bicarbonate concentration.
So that's looking at choice B right now, right?
What
you're saying? The one you were saying?
Oh,
Sorry.
C?
No, like which one were you saying to think about right now?
C?
Okay, so we're talking about this one right now? I mean,
Above that.
this one. I'm sorry.
Yeah,
I see what you're saying. Yeah. So you're talking about that one. All right.
So if the H2CO3 concentration is greater than the HCO3 concentration, that means that in that equation, in that logarithm, that denominator is greater than the numerator, right?
Okay.
So if the denominator is greater than the numerator, that overall number, is it going to be less than or greater than 1?
It's less than, right?
Yeah. So you can put in numbers if you want. I think that'll help you.
I kind of see what you're saying now. Like I didn't look at it this way because I get really sketched out with all the math. So yeah, I see that now. So yeah.
Yeah. So that'll give you so if C were the case,
it's going to give me a really small number usually, right? I mean, depending. Yeah.
Oh yeah. So basically, yeah. So if C were the case, the logarithm value will be something that is negative. So the overall pH will be equal to the pKa minus some value.
Okay.
Now, if you look at B, where the numerator is greater than the denominator, you're going to get a number that's greater than 1, right?
Yep.
And so the logarithm of anything greater than 1 is going to be positive. And so the pH value will be something like the pKa plus something. So something higher than the pKa.
Yeah, that answer makes a lot of sense now. Like I didn't think about it that way, honestly.
And then if they're equal, right? Kind of like we had that question. If they're equal, right, then it's just when you divide one over the other and they're the same thing, it's just 1. And log of 1 is 0. And then that log term like disappears. It turns into 0.
Yeah, that made that a lot easier. That makes a lot of sense. So that was actually not a hard question if I had understood that.
Mm-hmm. So let me ask you this: why? So okay, strong acids, right? They completely dissociate.
Yeah.
So that means that whatever the concentration of the acid is, like on the reactant side, right? It's going to be equal to the concentration of its conjugate base, right?
Yeah.
Because 100% of it dissociates, so all of that acid turns into all of that conjugate base. Right?
Yeah.
Okay, so that's why, like, for strong acids, right, the pKa is equal to the pH.
Okay, let me go through that again. So if it's a strong acid, it's fully dissociating, and that's why the pKa or the pKa is equal to the pH. So
because the log value because the log value of the conjugate the conjugate base concentration and the acid concentration are equal. Because all of it turns into that.
And that just cancels out.
Yeah, because then it's a log of 1, which is 0, and so the pKa is equal to the pH.
Okay.
But that's why they use that equation for weak acids, because then you're not going to have an equal amount of the two, and so it's going to be some.
Right. Yeah, because we're talking about the buffers and.
Yeah.
Gotcha. Yeah, I just used that in chemistry. I didn't know how to use it. That's how I got through school. Like, I didn't actually learn how that stuff works. And, not that they ever taught me really how it works. To be honest, I just plug and chug. That was chem for me.
Mm-hmm.
I got this one wrong for being stupid. I don't know why I went with that. That was obvious. I was starting to rush. I knew that. This type of question I've seen come up a ton about, the acidic. If it's the carbon or hold on, let me just make sure I understand this. They've gotten it wrong in the past, and I knew this time. Yeah, so like
yeah.
if it's the most acidic like compound, it has to do. I know it has to do with like the location in terms of like the the carboxyl.
Yeah, so
I knew it was closer to. I knew this one had more protons, but I knew this one was like I guess being pulled by two double O bonds, so I knew it was going to be like
uh-huh.
more acidic.
So think of it like, since okay, the MCAT is like entirely like critical thinking based, right? So think of everything like conceptually. So generally speaking, stronger the acid, the more stable its conjugate base is. You know what I mean when I say conjugate base? Like,
Um, kind of, sort of.
so like
Uh,
for like H2CO3, right? When it loses a hydrogen, it turns into
that's the
HCO3 minus, right?
that's the base conjugate base,
Yeah.
right?
And so
Okay.
if that conjugate base is stable, then that H that it loses, like, to be an acid, like, it's good. It wants to do that. So the stronger so the more the more stable the conjugate base is, the stronger that acid is. Because an
Okay.
acid, when it loses its hydrogen, when it loses its proton, it turns into a conjugate base. So if that conjugate base was not stable, right, it's not going to want to move in that direction. It's going to want to turn back into the acid before it gave away its proton.
Okay.
So like that's just like thermodynamics, which is like energy and stuff, and basically everything like in the universe has to obey those laws. So basically, we're looking at, so if you take a hydrogen from position A, right, it'll just have like a positive charge there, or no, or a negative charge actually, since you're losing the hydrogen, and it'll just be a negative charge on that end, right? But
Okay.
if you take the hydrogen from position B, you have a negative charge there. There's resonance where, between that carbonyl, like the carbonyl group, and the one here. I'm gonna draw this. So in the future, you can send me like these questions, and I'll just like take screenshots of them, and then
Okay.
I'll go over it like in like the notebook, like I'm going to do now. So here, I'm going to share my screen again. Can you see that?
Yep.
Okay. Okay, so let's say we have let's say we have a negative charge there, right? So wait, do you remember from Orgo things like primary carbocation and stuff like that?
Um, vaguely.
Okay.
Oh yeah, I know you're drawing. Okay, yeah.
Yeah, so all right, which one of these is the most stable?
Um, I'm trying to remember both. Is it the? I can't remember if it's the most substituted. Is that the one that's most stable? So it'll be the top one, right?
Yeah, followed by this, and lastly that, right?
Why is the one on the
Oh,
one on the end is on like the last one you drew at the bottom. That
Oh,
one
sorry.
is
Yeah, that's up here. My bad.
okay. Yeah.
Yeah.
So that one is least stable. Is it because of the
Because so there's something called polarizability, which is basically think of like something that's charged, right? If it's if that charge is spread out over like like a larger distance or over more molecules, right? More space, the charge density decreases. So for here, it's a tertiary carbocation. Well, this is actually an anion. A carbocation is if it's whatever positive.
yeah.
So yeah, so this charge is spread out across like this carbon, this carbon, this carbon, this carbon, right? So it's not like a ton of negative. Like it's not like a charge is just on one like atom. It can be spread out, right?
Okay, yeah.
And then secondary is like in between, but primary like it's just at the end over here on one atom, so it's not going to be that stable. So if you removed like this hydrogen over here, you would end up just like with a charge like at the end like that.
So is this getting into like since there's like that methyl group on the end, so like it's more stable than the CH2 that's in the middle. So since it's more stable, it's more difficult to pull off, right?
Oh,
Or
so
my mind might be going elsewhere. Like I'm probably thinking of other stuff, but
since this, okay, so this is not very stable, right? I haven't like given you like the other examples yet, but okay, so here I'll just do the other example. So this one over here, it has two things going for it, right? It's secondary, so it's going to be more stable, but it also has an additional thing. So here, I'll draw that. Okay, so if you remove this hydrogen, right, it's going to be like primary just at one end. And if you remove the hydrogen from here, it's secondary, right? So it's going to be more stable, but does it make sense that it'll be more stable?
sorry, say that again.
So if you remove like hydrogen from position A, and you'll get this over here.
Yeah.
Which is a primary like anion over here, carbo anion. I don't even know if that is what they call it, but if you remove the hydrogen from position B, it'll be secondary, right? Because they're like it's over here with the two carbons.
I guess like when I was going through it, the thing I was thinking about was the location.
Mm-hmm.
I mean, I wasn't thinking secondary in my head. I was thinking the location between the two double bond O's.
Yeah.
I knew because I was thinking of acidic or whatever, but like I knew.
Yeah. So okay, so this has the fact that it's secondary going for it, but it also has something called resonance stabilization. So that means that this is also going to be something like this.
Yep.
So in addition to it being like a secondary, like anion, it has resonance stabilization, which means that like a double bond or a lone pair from this oxygen. Wait, sorry. Which means that this double bond. No, what am I talking about? Sorry. Which means that Sorry. Wait. What were you going to say?
Yeah, I was just gonna say, like, I knew for the other side of the reactions, they had labeled C and D as well. Like, I noticed the ring structure up there. I was assuming that that would be a no because of the steric hindrance, but I don't know if that's related to that or not. Like, I just knew that
Are
would
you
be
talking
hard.
about that like?
Yeah, the ring
Oh,
structure, just the way it's laid out. I see like both. Like, one, like you can't get the sorry, what was the word you used about like moving the electrons, the resonance.
mm-hmm.
Like you didn't get that with that double low bond, but also like I know there's a steric hindrance, so it may have nothing to do with it. But I just saw that there was that big bulky molecule, and I just like,
Oh yeah. I mean, there would be like some resonance stabilization where, like, okay, let's say you got rid of this, and you got a negative charge there. It can go here, and then this can go there. And then you would get basically something like that.
okay,
Yeah. So like basically what like if this negative charge over here, that is basically, like two electrons that can go over here to make a double bond here, and then the electrons from this double bond would go to the oxygen to produce this over here. And then I guess I'll use purple to say if this went to this over here to make a double bond, and then this went up there, you'd get this over here. So you basically have, I'll use red. So you basically have a negative charge that could be there, negative charge that could be there, and negative charge that could be there, right?
yeah,
So overall, this means that this entire region, a negative charge can be anywhere in that entire region.
okay, yeah, I see that.
Yeah, and if you basically have, so like let's say, so stability is proportional to charge over, how should I put this, distance or area maybe, which is the same thing as like basically charge density. Like I think the term is polarizability. Let me look that up. Polarizability. Tendency of matter, okay, blah blah blah. So, all right. So the fact that the negative charge has all this room to exist in means that it's going to be overall a lot more stable than if it was just this, where it just has that small tiny area to exist at. And the strength of an acid is proportional to the stability of its conjugate base. Okay?
All right.
So like, H2CO3, let's say, turns into HCO3 minus plus H plus, right? If this is stable, right, then this can exist, right? And the H2CO3 would if the reaction would move forward, aka it'll be acting like an acid, right? But if it's not stable, then it should be going backwards, right? Like if it's not stable and it's more stable for it to exist as H2CO3, like not giving away its hydrogen, or proton, then it's not going to be a good acid.
Can we just like quickly circle back? I'm trying to make sure I get this. Like I
Yep.
get the lecture like negativity, the resonance situation. That's why I went with that.
Yes.
Like I know generally like I guess when I think of acidic, I think of a lot of protons.
Mm-hmm.
But you're talking about like the CH2 here, or whatever, involved like the conjugate. That's the conjugate base, like of an acid, right? Am I saying that
Oh,
wrong?
these over here. Wait. Or,
I'm thinking about the actual hydrogens on the molecule, or
Yeah.
like does that not have anything to do with it?
Wait. What about the hydrogens?
We're talking about up here with like the conjugate base. Like I'm just a little lost with that part. Like I just think of like something this acidic is like really protonated, I guess.
Yeah.
But
So
like I know this side's more protonated, but I knew it wasn't closer to all the resonance that was going on over here. Like I picked that out, but I was trying to
I see what
understand
you're
where you're
saying.
coming out with the conjugate base part.
Okay, I see what you're saying. So think of all right. Okay, this guy has more hydrogens than this, right? But it doesn't necessarily mean that it's an acid. An acid, like you can define that as it wanting to give away hydrogens. And if it wants to give away hydrogens, that means that it's going to be fine without that hydrogen. So like H2CO3, right? It has two hydrogens, right? And it gives one away to become HCO3 minus, and it's stable as HCO3 minus. That's why it can give that H away. And that's why it can be an acid. If it wasn't stable without the H plus, it's gonna be like, no, I'm gonna keep it.
Oh wait, yeah, because like that's why we dissociate all those protons and
Yeah.
acid. Oh man. Oh wow. Okay, that makes sense.
Yeah, think of like an acid.
I wasn't
as
thinking
being-
of it that way, but yeah. Okay.
Yeah, think of like protons like as whatever, some type of currency or something, or I don't know, like some like if an acid is just it's like someone who's okay with giving away something, because when it doesn't have that something, it's stable. So it's like,
Yeah.
you know, that's like the I guess, yeah, that's the connection I'm making here. So despite the fact that there are more hydrogens here, that actually doesn't really mean anything. It just like what we're really looking for is, if we take out a hydrogen from here, how is this guy going to, how is he going to be? Like, is he going to have like, abandonment issues? Is he going to be like sad because he lost a hydrogen? If he's sad because he lost a hydrogen, then he's not like cut out to be an acid.
Yeah, I think I get it now.
Yeah.
So
So
there's
think
a
of
lot,
like, yeah.
yeah.
Sorry.
So there's a lot you could like do with that question. Yeah.
Yeah.
That's a good big concept.
So like a really strong acid, it's like, it's okay with being complete, giving, all of it away, because it's completely okay being, a conjugate base. And a weak acid is like, like I'll give you some, but I don't want to be without the hydrogen. Like,
yeah.
So that's like the connection I'm making with strength of an acid and the stability of the conjugate base. And so in this question, like, you think like which hydrogen? It's almost like if I had to cut off your arm, which arm do you choose, right? If you're a righty, I'm a righty. So if you cut off my left arm, I'm going to be more functional, like losing a left arm because I use my right arm, right? But if you take off my right arm, I'm going to be less functional. So the the hydrogen that's labeled A is like a right arm hydrogen, if that analogy makes sense. Like, the guy needs it. He's very unstable without it. Whereas B is something that he doesn't need. He's very stable without it. And that's because of two things. One, it's secondary, so that expands, the space that negative charge can exist. And 2, there's resonance stabilization. So, that means that the negative charge can be here, can be here, can be there.
Okay, cool. Yeah, I don't think I would miss that. That was pretty in depth. That was cool. Yeah, I've seen questions like that come up quite a bit actually. Like I've seen at least 2 or 3 like that.
Like what? Which?
Like exactly like that with the proton. Like which one's most acidic? Yeah, I've probably seen it in U-Roll, and I've definitely seen it. I think AAMC I've seen one like that.
Yeah, I just found this on Google, whatever. For the carbon cation, same thing, just with positive charge. So in terms of least stable to most stable, tertiary most stable, secondary just attached to 2 carbons. Here, I think that
just to reiterate,
the H's mess things up. I'm gonna try to use a different one.
Okay.
Wait, what is this? Okay. All right, here, that's better. So okay, now it's most stable to least stable, but you see tertiary, that charge has all this space to loosen up and chill, right? And relax. Yeah. Secondary, it's no, you can't go in that direction. Primary, it's no, you can't go here. But you have the most freedom here. So yeah, so stability, think of and also it's how I say it's good to think of things in ratios. I'm thinking of charge over area, basically that kind of thing. But okay, what were you going to ask me just now?
I was trying to make sure I'm getting which one, secondary. All right, so the second, so what we just circled, the double O anhydride or whatever that is, that's secondary, right? Because it's connected to 2 different.
This one?
Yeah. Okay, so that's secondary. The one on the left of the hydrogens, is that primary or is that the other one?
This one?
Yeah.
Oh yeah, primary, yeah.
Okay, cool. I was just making sure I had that down right. So just to reiterate, make sure I understand this. So the secondary group is more stable, so we want to keep that one. And the methyl group is the least stable, so.
Oh yeah, that's yeah.
Yeah, so that's why that's why it doesn't really want to dissociate. Okay, cool. I got this question now. There's a lot of content going there. Understand, that's cool. I get it. Okay, awesome.
Yep. Yeah, it's the stability, secondary, primary. It's the resonance stabilization, and and then the fact that the strength of an acid determines on how stable it is when it gives up that hydrogen.
Yeah. Cool. Okay.
So, yeah.
Oh yeah, I got this one wrong about the. Can you see my screen now? I got this one wrong. I think that's just because I misunderstood misunderstood something about this.
Oh yeah,
so
reverse transcriptase. Have you heard of that in HIV?
Yeah, I'm familiar with reverse transcriptase.
Yes.
I think I didn't understand. So if they give you I know they give you these different types of questions with strands. So I know if it's if they gave you an RNA sequence. I'm gonna try to explain this. If they give you an RNA sequence, the matching or the other strand's just gonna be that sequence itself. But I got this one wrong. I knew to replace the A with the U and all that. Because it was RNA or whatever. I mean, swap it. I knew that this was. What was my train of thought? Hold on a second.
Oh, I see what you're saying. You're saying on the opposite strand.
Yeah, I was just losing my train of thought. Yeah. I think that I said, I just kept going. I wasn't reading it backwards. I wasn't reading it.
Yeah.
because like I know sometimes you just leave it alone, and it's just like I know it's like template versus the coding strand, I guess, or. So like this one, I think I just like kept it like I was reading 5 to 3, and not flipping it backwards or reading from the 3 like backwards, like saying that was GTT from 3 to 5.
Mm-hmm.
Like I know they're 5 to 3 both ways, obviously, but like I think I just matched it up. If that makes sense. Like
Yeah,
5,
I'm curious
3, 5.
about why you chose something with U's in it though. Because well, okay, so tell me what transcription is.
Just it's where you're transcribing DNA to RNA, then
All right,
you go through.
and so reverse transcriptase should do transcription in the opposite direction, right? So like RNA to DNA.
Yeah.
Okay, so you can get rid of like the first like choice A and choice C because they have U's in them, right? Because you're making.
Okay, so I know what I was. So what I was I think what I was doing is I was thinking of another situation. Like I was thinking like.
You were thinking which sequence would reverse transcriptase use to make the DNA strand, right?
Yeah, so I was saying like it is the. I think I was trying to say what the RNA strand was.
Mm-hmm.
I think it just got caught up like.
Yeah, so like what you chose, that is the what is it? This is the template strand, so like the coding strand, I guess, because the thing that you chose, the 3CCU, that would go directly underneath what they gave us.
Yeah, that's what I did. Yeah, like I was thinking CCU, like I was doing it.
Mm-hmm.
Yeah.
Yeah.
So that would have been if it was. So this is an RNA strand, right? Yeah. So this was an RNA strand. I was just thinking to complement. I think I was thinking complement the RNA strand. I think that's what I was thinking. Yeah. And I knew what reverse transcriptase was, so I should have just.
I think what gives it away is where it says using this RNA as a template, right?
So we were looking for the coding strand then, since we were starting with the template strand.
Yeah, and I think you made a new template strand. Which is good. It's good that you know how to.
Oh wait, no, yeah, that's what I did. Yeah, I was saying I was going from the 5 to 3, starting at the G. That's what I did wrong. Like because I know there's a situation where if it's like there was an AMC question, it was RNA, but it was like the same RNA. I can't remember the way they worded it. It's whatever. Yeah, so I just did it like backwards basically.
Mm-hmm. Yeah.
So I should have done DNA because it was. The reverse transcriptase using RNA2 DNA, which I knew. So, yeah. Mm-hmm. Good move on my end there. Yeah, I got this one on because I was being...
what was that question about the uneven distribution?
Back here.
Okay.
Yeah, I just knew the...
yeah.
Yeah, I knew that basically all those were wrong, and I got the D.
By the way, anytime
I was on the opposite. Some reason, I guess, again, getting rushed, I chose the opposite answer.
Mm-hmm. I was just going to say, whenever you see pi bond, think double bond.
Yep.
And also think resonance. Okay. More on that later, but I want you to like start making like these like connections between like various different stuff because they'll ask you stuff like in different ways. Yeah, sure. And like dipole, that's just like the difference in like charge, right? Or electron, electron distribution. That's why I went with that. I mean, I knew these answers were just like distractors. Like I didn't think they had anything to do with the Yeah, I got this one wrong. I said the opposite. So diaphragm contracts. I went volume of lungs decrease, pressure increases. Oh yeah, this is weird. I thought it was weird too when I first learned it because for some reason when the diaphragm contracts, your the volume in your lungs goes up because for some reason it makes you think the opposite.
No, like I'm
wait,
sitting
wait.
there like during
Yeah.
the test breathing and like I'm
Mhm.
breathing in and exhaling.
Yeah. But
Listen,
yeah,
I'm an
it's
ex-phys major and I'm getting this mixed up. I was just like, what the heck?
yeah because it's weird because it makes you because it doesn't really it's not really intuitive to think that if something like contracts, because when something contracts it gets smaller, but for some reason when the diaphragm contracts like it goes down.
Yeah, I was getting confused. It's diaphragm, it's contracting when we're exhaling, right? Or is it
um
inhalation? Like, I was getting that mixed up. Like,
so when it contracts like it goes down, which pulls and makes like the volume of the lungs larger. And if the volume is larger, the pressure is going to be smaller. And if the pressure is smaller, that means it's going to be relative to the outside pressure, and that means you're going to inhale.
okay, yeah, I just need to revisit the lung physiology a little bit. I don't see this come up a lot, but like, I don't want to miss something. I mean,
Yeah.
that was I went the opposite answer choice. Like,
But the thing that you asked me, like, do you see how I like can like I guess I like used so like basically like I said basically like the volume, if the volume of the lungs increases, the pressure is going to decrease.
oh yeah, they're inverse relationship.
Yeah, and then
Yeah, see, I didn't sit there and think about like
it's gonna go in.
Yeah,
That's how I could answer it. That's inhalation.
okay.
But
So
yes,
yeah,
the thing about the diaphragm, yes, when I first saw that, it confused me too. But like, I think it's something like the diaphragm relaxes. It kind of looks like this or whatever. Like, and the lungs is on top of it, and then when it contracts, it goes down. So the lung, if the lung like capacity or whatever is above it, and it goes down, there's more lung like volume, right? That here, let me try to look at the diaphragm, because that it's a weird thing. I thought it was weird as well when I first saw it. Like, because it's the thing that's like underneath here, contract. Yeah, it goes down. I'll just put this link in the chat right here.
yeah. Something else to revisit.
Yeah. Wait. Yeah.
Yeah, I remember like having to like brute force memorize a lot of that stuff for phys.
Yeah, so just I guess remember that when the diaphragm, contracts, it goes down.
So that would be exhalation, right?
So okay, if it goes down, what happens to the volume of the lungs?
It's deep is increasing,
Yeah. And if it
yeah,
increases,
increasing,
what happens to the pressure inside of the lungs?
decrease.
Decrease, right? And so it decreases relative to the atmospheric pressure, right?
Yep.
So the pressure outside is greater than the pressure inside, so where is it going to move? Like the air.
Say that again. So like the pressure outside, is it like our system's greater? It's lower inside.
Yeah, so the
Right.
pressure inside of your lungs is less than the pressure outside of like the air outside. Right?
Yeah.
So where would the air move? From outside to inside or inside to outside?
I'm getting lost. Outside, inside.
So let's say like I have this water bottle and I dip it in a pool. Water is going to go like it's not full.
Yeah.
If I dip it in a pool, water is going to go from inside to outside or outside to inside.
Outside, inside.
Yeah. because this is not filled, right? So there's a lot of empty. There's like an excess volume here, so less water pressure. Whereas when I submerge it inside of a pool, that's completely like 100% water. The pressure of that water is greater, and it's going to push all that water inside. So the same thing goes for in your lungs. If you're if the partial pressure of like, you know, the gases inside of your lungs is less than that of the outside environment, the air will be like it'll just be pushed from something that's from a place of high pressure to a place of low pressure, so it'll go inside. So you'll inhale. So diaphragm contracts, lung capacity, lung volume increases, lung pressure decreases, pressure outside greater than pressure inside goes inside, so inhalation.
Okay. Yeah, I probably need to revisit that. Just kind of like.
Yeah, because that's like putting like all of like Boyle's law and all that stuff into play, or like Charles' law and stuff like that.
Sure. Yeah. And sometimes I have issues like this question. Sometimes I get them right, and sometimes I have issues with these kind of like again, we're talking about like
this is like proportionality stuff that like I always like kind of talk about. You even saw me use like the proportional symbol. Yeah, okay, so what were you saying about this?
Yeah, this is like kind of stuff I get wrong. So which graph best represents expected relationship between time of H2O2 during reaction 1 and reaction 1 was?
Okay, so let's see. Peroxide turns into water and oxygen. The rate.
Yeah, so I was thinking like over time, you're going to get more. Like as long as you have enough of the reactant, you're going to get more product over time, right?
The rate, okay, is increased by the addition of a catalyst. Okay, that's not gonna help. Let's see. I think it's gonna have to do with the rate equation.
Oh, you mean like rate law? Yeah, I don't have that stuff memorized, but you're probably right.
Yeah.
Yeah, first order. The reaction was first order, so that's I was thinking of it in terms of like,
Oh, and I definitely don't think that they'll ask you like with this specificity, like knowing the difference between. Well, actually, I mean, I don't think they'll ask you that, but like you could figure like after I work with you, you're gonna be able to figure out like how certain like the natural like ln natural log, right, and then. So okay, let's look at it this way. So, forget the natural log part for a sec. Okay, this is gonna be kind of complicated, because all right. So if it's zero order, right? There's no proportionality, so it's just going to be like it doesn't matter how much time passes. It's just gonna be like this.
Okay.
So that's what C is.
So zeroth order, it's just gonna like flatline. There's no like. Okay.
Yeah. So that's C. Okay, now, all right, now if it's first order, right, it's going to be related to the concentration. So it'll look like the line in choice A.
Okay.
But choice A, the y-axis is 1 over peroxide concentration. So that just makes it a little bit more complicated, so we're not going to consider that. But that would be like, you know, the answer if it wasn't like the reciprocal of it.
Okay.
As for choice D, like you would think that that's how a inverse proportion would look like, but it actually would look like a curve, and I'll go into that like another time because I want to ask you like specific like math things because it has to do with that. Now, okay, just the natural log thing, it's like that's just like a way for them to take something that's like not going to be producing a straight line and making it produce a straight line. That's the natural log aspect of it.
Yeah, I think when I was going through this question, I was actually between these two, just thinking of like them asking about the relationship, and I was like, well, the H2O2 over time would be used up. I guess I was trying to relate it to the I can't think of what it's called now. The oh, I can't think. Like, you know, where you have like more product and reaction, like which way it's gonna go, like which way the reaction's gonna feed forward or not.
Yeah.
So I was thinking like, oh, we're gonna run out of this over time, so it's gonna be decreasing.
Uh-huh.
I don't know if you're with me there. Like that's what I was thinking. Like
yeah. So yeah, you're thinking of Le Chatelier's principle. It says oxygen gas is collected, so we're not going to have any more of oxygen gas, so it should be going like forward completely.
But I also wasn't taking into account, because again, it was going fast. Like down here it said rate is K to it gave equation 1. I wasn't even paying attention to equation 1. I was, for whatever reason, I was distracted by it. Well, it said reaction 1, but I guess I did not think to look at equation 1 here. And I think if you had to memorize, I think that the rate for this one is the graph shows natural log or whatever.
Okay, so okay. First of all, everything you said was right about Le Chatelier's principle. Like if oxygen gas is that's produced is collected in a chamber, and we can't get it back, it's going to be pushed in the forward direction until you use up all of it. Everything you said about that is right. However, since you're saying over time, right? That means that it's a rate. Like a rate is going to be like something involving time, like rate of change for distance, right, is velocity. Rate of change for velocity is acceleration. So since they're giving us time as a independent variable, like aka the x-axis, and they mention that in the question, that means that we're going to deal with the rate, the rate law.
Okay, yeah, that's a concept I was unaware of, but that was a good try for that question.
Yeah, and yes, so they're saying basically the same thing with that I said with A. Let's see, second order process. C. So basically the if you put a natural log in front of something, you're going to make that linear.
Okay.
Yeah. I'll like yeah, I have that in like the notebook where I talk about why use logarithms.
Okay.
Like, yeah, for instance, like, let's say you did a graph of H plus concentration. It's going to be like a curve, right? Because it's going to... But if you do it by pH, which takes a log of it, it forces that curve to become like a line. So I'll go more into that. We'll do like a dedicated like math like kind of thing.
Oh yeah, wait. That's definitely my biggest weakness.
Yeah. So I didn't realize we're like a little past 2 hours. Do you want to what do you want to do? Do you want to do like another like?
Yeah. You want to do like 30 minutes?
Like,
is that okay? Or...
Oh wait. Like 30 minutes? Like wait,
yeah.
2 hour 30 total. You're saying?
Yeah.
Okay. Yeah. So like 20 more minutes. You're saying?
Yeah. We can try to like get there.
Got it.
The main ones. There's another math one. And I'll go ahead and like stop real quick and ask like, I was supposed to take my test in 4 weeks, and like I put my application in. Like I have a good application, but I probably need to push my test back a little bit. Like, I don't know. Like, what's your advice? Like, what would you try to like do at this point? Like, I don't need a perfect score, but I would like to score, maybe 508, 510, somewhere in there.
Yeah.
Like I don't know, like what would you try? Like you kind of see like I have some stuff. Like obviously I know some stuff. Like content wise, like I don't know. I know you haven't worked with me that long yet, but like I'm just trying to pick your brain.
Oh yeah, yeah. I think going over a lot of like the math stuff first will
Yeah.
be something that'll provide you like improvement like in every area. And then we can go over uh, basically how to like make sense of like passages.
Okay.
And as for like the content, like in between our sessions, like definitely like look at the questions that you got wrong, and then look into the content that you may have some like holes in, like you're in the stuff that you don't know, and like look up that content, see if it makes sense. If the content still doesn't make sense, we can like when we meet we can go over that.
Okay.
All right, I'll be right back. I'm just using the bathroom real quick.
Yeah, you're good.
Okay. Let's see.
Yeah, so I was saying like my test was supposed to be July 22nd, but like I'm saying like I would like if I need to wait, like it's not gonna like make or break anything.
Mm-hmm.
If it's a few weeks or something, like I don't know, like I do work too, but I don't know what like you think.
What's
like,
what's your like what's your schedule like? Wait, did you hear? What's your like schedule like?
So I actually work from home, so it's not like I can make time to study. It's just harder. It's harder certain days that are busier.
Yeah.
Like I have full weekends, and I can probably make. It depends on the day. Like I can probably like 4 to 6 hours.
Mm-hmm.
I've just been doing a lot of questions. Like I said, I've already gone through over half the AMC stuff. I'm halfway through your world.
Yeah,
I'm good. Like I'm good to go. Psych Soch. Like not worried. Got it down. Scoring like the last FL was 129. It just seems like the Chem Phys and Bio is not going up much. Now Bio Chem, like I fluctuate. Like I've gone as high as like 128
and
practicing
120.
Now granted I'm doing a lot of the Altia, so I knew those would get a little low. I'm just trying to like learn from it.
Yeah.
And get my timing down. That's why I've been taking like 1 to 2 practice tests a week. I don't know if you would if you think I should like cut that back and do more like
So it
practice or
depends
what?
if you're all right. So can you do you think you can get to a point where you can do more than like 6 hours?
Like I guess I could just like not sleep.
So maybe it would be better to push the test back, because there's nothing, you said like there's nothing, like no requirement for you to take it like in a month.
No, just the longer, like I am getting my application in, so like the longer.
I see.
Yeah,
That's
where I'm at. And like I said, I'm planning on applying in state, so like I'm not worried too much about my score. As long as it's like decent.
Yeah.
Obviously, if I had more time knowing now, like I would have done things differently. But
Yeah.
I do want to still try to apply this cycle to at least my in-state schools. And I know like with in-state applicants, like I don't need the highest score, and I can still get in.
Yeah.
Yeah.
Okay, because I want you to be able to first like be able to be comfortable with, with like the math stuff. That stuff like I made like a video about this, like where I go over like the majors and how they do on the tests,
Yeah.
and just how like math, science, and like physical science majors, like they score like the highest, like even like higher than bio majors in the bio section.
Yeah, it didn't help me at all having bio classes.
But like it's doesn't it make much sense, right? Because but it does. Like, it doesn't initially, like, at first make sense, because it's the same, if you look up, like, LSAT scores by major, or, like, GMAT scores by major, GRE scores by major, you see that same pattern, and it's because if you have, like, a very solid, like, mathematic, logical kind of foundation, then you can kind of, like, do anything. So I want you to be able to get to the point where you can, like, think in those terms, like in terms of like connecting the things, like when we were talking about before with like the diaphragm, and then connecting it to volume, and then connecting that to pressure, and then how that interacts.
Yeah, for sure.
Yeah, it's like all inference and stuff. So yeah. So if your test is in July, yeah, when is it in July?
It was supposed to be the 22nd, but I have time. Like the way they have it, where you can reschedule for free right now. I have time. Like I can reschedule it, like if I have to, which is fine. Like if I have to push it back 3-4 weeks or whatever, like obviously it's better if I can get plus 5 points or whatever than take it and not do well again. So
yeah, yeah. See what you want to do with that. But okay, so all right. So I guess we can do. All right. Do you want to do this problem?
Yeah.
Okay.
And I knew the formula right away, like PV is nRT. And I think I tried to. I think I didn't know how to convert torr to
Okay.
to like the pressure. I think that's where I messed up, because I plugged everything else in. Like I knew.
Mm-hmm.
I left this in liters. That was fine. I converted that to Kelvin. I was good there. And this, I could remember.
Yeah. Okay. So a couple of things. So the ideal gas constant, capital R, there's different versions of it. The version of it that involves liters and ATM. I always say like fractions are like the best things to use, and I just like found out that 1/12 is the same thing as 0.083, which is the ideal gas constant in liters times ATM over moles in Kelvin.
Okay.
So that's like a good thing to use. Like I'll share all this with you.
Yeah.
And then you should also know that 760 torr is equal to 760 millimeters of mercury, which is equal to 1 ATM. So
Okay.
Definitely.
I think I was trying to say like 750 ATM or something. Like I was thinking they were interchangeable. I don't know. Like
yeah. Definitely. Definitely have to know that those values. Okay, so let's see. The vital capacity, I guess, or whatever. Yeah. Is the maximum volume of air that can be exhaled following the deepest possible inhalation. All right? Average adult, 4.8. Oh, for male, 3.1 for women. Okay, let's see. So this dude gets it done. It's 4. Oh, wait. It's 0.43. Okay. So I guess he's not very healthy. All right. Was recorded by the technician at temperature, which also you're going to change to Kelvin. Okay?
Okay.
Generally speaking, always it's best to use Kelvin. Why do you think? What's the difference?
No idea. I just do it.
Okay. So what does Fahrenheit and Celsius have that Kelvin does not have?
I'm trying to remember. Like I know it has some. There's a reason why they made Kelvin. I just can't remember.
Mm-hmm. So what? But what?
Absolute. Does that have to do with absolute? The temperature? I can't remember.
Kind of.
Yeah.
Just don't worry about like remembering. Just almost like clear your mind and let like your own like intuition kick in.
Yeah.
So you said like absolute zero, right? That's
Yeah.
like the lowest temperature for Kelvin. How many Kelvin is that?
It's zero. Wait.
Yeah. So the
Yeah.
lowest temperature in Kelvin is 0. Whereas for Celsius and Fahrenheit, lowest temperatures will be negative stuff, right?
Yeah.
So basically, Kelvin means that there's no negative values.
Okay.
Because the negative values can mess things up greatly. So that's just one of the good reasons for using Kelvin.
Okay.
All right. So yeah, and this is just like how I'm gonna like teach. Like I'm gonna ask you like questions and like kind of like focus on like the why and stuff.
That's good because I just tried to memorize.
Yeah,
like,
yeah.
I mean, that's what we did. Like, that's how I got good grades. I just memorized
Yeah.
everything in my textbook and wrote it down.
Yeah. So that's why like these like standardized tests exist because they have to be able to tell like, you know, for like it's always like that. Like they need to have like if you can memorize and do well in school and study, then your GPA is going to be high. But then the flip side of that is like, can you like think critically? So there's the SAT, the ACT, there's all that stuff, and you know, sometimes people with like high GPAs have trouble with the standardized test part. Sometimes it's the other way around, but yeah, it's going to be different from like learning it in school. It's in a good way and in a bad way. In a good way, or rather in a bad way, if you think like, oh crap, like I learned this, but I'm still not being able to like get the score that I want. But in a good way, because it means that you don't necessarily have to put in you know, just a tremendous amount of like content in your brain. It's more like a test like the MCAT. It's less about what you know and more about like taking out that which stifles you and lets you like think kind of clearly.
No, that's what I can't do. That's why my scores suck because I know a lot of content, but I can't apply it. And I'm like constantly go through questions, like trying to like, oh no, what did I forget? What formula was this? Like, how do I get to this? Like, I constantly forget.
Yeah,
like, and like, that's why you're probably seeing like, there were things like I knew, but like, I either missed it in the passage or getting overworked up on a question.
Yeah. And if you know the why of something, like you'll never forget the what. Because if you forget the what, you can use the why to figure it out. Like, for instance, I did not have memorized diaphragm contracts inhalation. I didn't have that memorized. But I just did the logical steps. Because there's no, like, you can have, like, a supercomputer that knows, like, the answers of every single MCAT ever designed. And there's no telling that it's going to like necessarily do well on if you gave it like a new MCAT, because they're going to be asking you like new things and to do weird things with those new things. So anyway, so let's see. So all right, asthma, right away. Like it's because he has a low vital capacity, right?
Right.
Like literally like a tenth. So, anyway, these are just some of like the observations I'm making. Like, you want to like have a very like active mind, I suppose, when you read this. So, like, I kind of like read VC. I saw VC, right? I'll just go into like how I'm like thinking. So I see VC, then I go to the passage where it says VC. It says it's the maximum volume of air that you could exhale after the deepest possible inhalation. So I mean, that basically means like you're inhaling as much as you can, and you're exhaling like that amount.
Sure.
And
yeah, we use those in exercise science a lot for athletes.
Yeah. So there you go.
Yeah.
Spirometry, right?
Yep.
Yeah, mine's probably low because I smoked for like so many years, and now I'm
really?
vaping. Yeah. So mine's probably like it's definitely less than 4.8, I would say. But anyway, so and then I saw 4.8 is normal for men, and then this person has 0.43, so it's like a tenth of that. And then I see temperature. Why are they giving me temperature? Like, if you see temperature and you see they already gave us volume, we're definitely going to have to use some ideal gas law stuff. So I see temperature, all right? And then, right away, like, you'll be fast with this too. Like, I see 25C. I know that's 298 Kelvin. And then I see 750 torr. I know 760 torr is 1 ATM. 750 is too similar to 760. Like, I could do the math, but I don't really want to. Like, it's basically like 1 ATM. It's just going to be a little lower. Okay, let's see. Oh, crap. They have some more stuff here. Okay, so they said using the spirometer. So now I have to actually look at the spirometer stuff. So this, okay. Blah, blah, blah. Okay, vapor pressure of H2O. So tell me what vapor pressure is.
I'm not really familiar with that concept. I mean, I've heard it, but I don't really know it.
Okay, so there is technically a difference between so okay, let me put it this way. So like water, right? Like if this was in plastic or whatever, like let's say like I put it on the stove to boil it, right? Eventually it'll evaporate, but we treat that as like water in its gaseous state. But vapor pressure always exists. Like if I don't have like a cap to this, but if I did have a cap to it, or here, I have a cap to this. So since it has a cap, right? It's not exposed to the outside atmosphere. So little tiny particles or molecules of the water in this and other fluids naturally jump up and enter into the vapor phase, and they just like hang out up in this like region.
Okay.
And that's vapor pressure. It's because it's the vapor that's on top of like the liquid, and since it's in a closed container, it produces a pressure that presses upon the liquid. All right. Now,
Yep.
if I were to like boil this, like by adding heat, it'll cause more, and because heat is basically going to increase the kinetic energy of the molecules, right? So, a lot more of these liquid molecules will be entering into the vapor phase, right? And then if I open the top, right? Once it gets to the point where the vapor pressure is equal to the atmospheric pressure, it'll boil. So a couple of that was a couple of things there. So basically, if we look at that diagram of the water-based spirometer, right? Yeah. So it basically whatever, it floats. You exhale into that tube, that tube like floats in there, and that thing is water, right? And then there's a chamber. So the vapor pressure, so that water, some of those molecules of liquid water, like basically get through like the surface and enter into the vapor phase, and they just like hang out. They bounce around up there in the chamber, and they produce a pressure down against the water, and that pressure is 24 torr. Here, I am going to send you this in the chat. Why don't you click on that? I think that'll make it easier to see.
I don't know why I can't go to chat right now. Oh, here we go. Okay.
Oh, were you able to see what I sent you?
Yeah. There's 2 links. Did you give me 2 links?
Oh yeah, the other one was about the
Yeah,
diaphragm.
Cool. Yeah. Let's save these for favorite.
Yeah, so the second one, you see basically evaporation, like, when it's like, the container it's not like a closed container. And
Okay.
then on the right, it doesn't even say it, but on the right, it's vapor pressure. So, like, that's in a closed container, right? And
Okay.
basically just parts of the liquid water that get passed to the surface, they enter the vapor phase and they hang out in that region where there's open space, and they just bounce around there and they exert a pressure against the
Container?
against the container and against the liquid water as well.
Okay. Yeah, I kind of like seen and heard that concept, but like I don't really know it that well. So I'll make sure I go through this and that other link you sent.
Yeah. So okay. So now if you can imagine that in that diagram, like where there's that spirometer container or whatever, like imagine like little molecules of water in the tank just bouncing around up there in the chamber.
Gotcha. Yeah, I see that.
So that exerts a vapor pressure, right, of 24 torr.
Okay, that makes a lot more sense. Yeah.
Yeah. So if you want to find the actual pressure of the gas, right? Because they're saying that this is all done through the spirometer, right? And since we need to use the ideal gas law, we need to find the actual pressure in that in the ideal gas law. And
okay.
And so that's just going to basically be the the total pressure, the difference of the total pressure and that vapor pressure.
All right, can you say that again? So is that to find we're taking the 750 torr and subtracting it by the 24 torr, the vapor pressure, I guess, that's being exerted on the container.
Yeah.
That's giving us is that actual pressure, what we're getting from that, or am I saying that wrong?
So you're getting some pressure from, so when you exhale into that tube, right, and it shoots up into that water into that spirometer chamber, right? That's like pressure from the dude, and then so that creates some pressure that's gonna go moving like in the opposite, like upwards, right? And then the vapor pressure of the water, which is going downwards, is gonna be moving against it. So the total, So the pressure.
So that's the pressure of the 750 torr is what's going in
Yes.
to the container, and we're subtracting the water pressure and the against. Yeah, all right, that makes more sense. Yeah, I got it.
Mm-hmm. Yeah. So yeah, you subtract those, and then you get your p-value, and then you already have the v-value, which is 0.43. I would just write like, I don't know, like 2/5. I'll have you like get good with like whatever fractions and stuff. Okay. Also.
Yeah, I could have solved it if I had known to do that with the torr, and then had that was 1 ATM. So wait, we subtract that, and it gives us 726 torr, but don't we have to convert that to ATM?
Yeah. I would leave it.
Would it make a big difference if I just said 1 ATM? Like,
I would leave it at 1 ATM, and then I would like know that the answer would be less than.
I like that method. Okay.
Yeah. So here, I'll do the thing where I screenshot or whatever. Okay, let's get this tablet open. So slow. Okay, I'm going to share my screen right now. All right. Okay, so you know, here we go. PV is equal to nRT, right? They're asking us to solve for n, right? By asking us the moles. Right?
Yep.
So that's n, right? So I'm going to rearrange the equation first. So n is equal to PV over RT. Right?
Yep.
Okay. All right, now, so yes, P is equal to whatever, 750 torr minus 7, or minus 24, I think, yeah. Yeah, 24 torr. Whoops. So that's like, whatever, 726, I guess. Torr. Yeah, I'm just going to, I mean, I can, I'll show you some more math stuff later, but I'm just going to basically just do something like this. 1 ATM, oops, why am I writing atom? Something like less than, something like that, like 1 ATM. I'm just going to use it, and let's see, so that's for pressure, and then let's see, volume is 0.43 liters, which is basically which is basically 2/5 of a liter, because 1/5 is 0.2, 2/5 is 0.4, 3/5 is 0.6, 4/5 is 0.8, 5/5
Okay.
Yeah.
I like to use. I would have thought to do that, but
yeah, a lot of people don't like. I like to use fractions because things cancel out a lot of the times. R, right? So you know it's this.
Yeah, is that the one you said 112?
Yeah, I'm just gonna use 112.
Yeah, I have that memorized now.
Yeah. That's a that's a good one. All right, and what was the okay? And then temperature 298 Kelvin. So we basically have everything that we need, right? We can just plug it in now, and whatever we get as our answer, it'll be a little higher than what our actual answer should be because we're using 1 ATM when it's less. Slightly less, and it's also I'm using 0.4 instead of 0.43, so it's going to be slightly less again. So anyway, now I'm going to plug these in. So n is equal to 1 ATM times 2/5 liters over 1/12. I'm not going to write all that. Fine, liters times ATM over moles times Kelvin times 298 Kelvin. Man, I should have given myself more space for this. So, also, if you divide something, it's the same thing as multiplying it by its reciprocal. Do you know what I mean by that?
Yeah.
So, if I'm dividing this by 1/12, I'm going to just multiply it by 12.
On top, right? Yeah.
Yeah. So,
that's okay.
So, I'm thinking of just making that 300 Kelvin down there.
That's what I would have done, yeah.
But, so we'll get something even lower. Wait. Yes. Okay. So, whatever. I'll just write, all right. Oh, geez. I can't believe that. All right. Sorry. Something happened here. Okay. It, like, zoomed out and made this line. Okay, so so 2 over 5 times 12 times 1 over 300. Does that kind of make sense, what I did right there?
Yeah.
Like,
Would you go ahead and just say 1/5 over, and then cancel out the 2 and 300, or
Yep.
I mean,
that's what I'm gonna do. 150, and then can I do anything else here?
I mean, would it hurt anything? I mean, I don't know if like it'll mess anything up so much if you change like. I guess would it make it too much of a difference if you change like the 5 to 6 and like cancel out 1, made that 2, and it's 2 over 150.
All right, let's do it. I like what you're saying. So if I made this guy a 6, or I can make the top one a 10.
Okay.
We can
that's
do
actually easier.
We can do a couple of things. I mean, I'm just gonna.
Because I mean, you just have to be kind of close. You just have to be somewhat close. Like I know you can have some major room there. The math.
Yeah, I'm just gonna do that. Oh wait, that's. So I get something like this. And so I guess like, I just know that 1 over 7 is equal to 0.14. So 1 over 75. Oh wait, you know what I could just do? Wait. Oh no, never mind. I was thinking, okay, whatever. So 1 over 7 is 0.14, so 1 over 70 is 0 or 0.014. So this one will be something like that, okay? It's like, oh, sorry. It'll be some number like this, right?
Okay.
Let's see, 1.4 e negative 2. So if you look at your choices, so that's the answer I get, right? Using like a lot of approximation. And all of this produces something. Our real answer should be less than this, right?
Yeah.
So we're looking for something, but not like significantly less, right? Like not like order of magnitude less, just this number. So over here, oh wait, 1.4. All right, I guess it's not less, but anyway, I would just look at the choices. Closest thing is 1.68 by 10 to the negative 2. It seems.
Yeah. The fraction way was cool. I like that. I'd have to practice my fractions a little bit, but that beats. Like I usually just do everything scientific notation and just try to round the decimal as fast as I can, and that still takes a while. So.
Mm-hmm.
Yeah. Cool. Okay.
Yep.
Awesome. Can I like Venmo you, or like what do you want to be paid on?
Oh yeah. I'll do it through Venmo is fine.